we are happy to be back for the next season, on LLMs and advertising. So, and this year we present you our talk about the recent trends in LLM-based advertising. Oh, it works. Okay. We've already introduced ourselves. So last year, at the previous summit, we talked about advertising in AI-based chatbots. So we pointed out the most likely ways to insert ads into LLM-based chatbots, and we introduced the concept of blended ads. So those are the ads that are the integral part of the answer, and they're like indispensable part of the answer. And we suggested several approaches to blocking them. And over the past year, we've been following developments in both industry and academia. The LLM industry was quiet until July, with all the major players having manifested themselves in 2023. And one of the most important developments was that it became cheaper to create ads with just help of ChatGPT. Things got more exciting starting in July 2024 with the announcement of the first LLM tuned for ad creation and evaluation. I don't know if you've heard of LLM Spark. So they advertised them at the first LLM for ads. We have also noticed a growing number of research papers being published, mostly by Google affiliated researchers. And they focus on dynamic and blended ad creation. So what is this talk about? So here's the plan. First, we'll refresh a couple of important LLM concepts to help us better understand the rest of the talk. Then we'll see how LLMs are used today and how much they cost. Then we'll try to figure out who pays for that. And next, we'll explain why we believe that more ads are coming soon. And then we'll see how blended ads have evolved since last year and look at how we could block them using an LLM. And we'll finish with a little demo. Sounds good? Okay, let's start. So what is an LLM, like in a nutshell? This is going to be the shortest introduction ever. So we need these concepts, and a few important concepts about LLMs, just what is an LLM and what's some other things. So a large language model is an algorithm designed to understand and generate human-like text. We'll know that it's a mathematical model of the language that has seen terabytes of text, scraped all of the internet that it could scrape, and those parts that it could not and it should not, but it did. And it broke all the text down into elementary particles, like the most common, we call them tokens. And somehow they learn dependencies between different words of groups or groups of words. And what follows what, which letters occur more often together, and so on. So these dependencies and all sorts of classifications are called parameters, and the latest models have billions of them. And it takes just months for the current generation models to be trained to understand. So Andrey asked me to do an explanation for a 5-year-old. So because these models, they use deep learning models, it means that they're supposed to learn by themselves. So what happens? So we have a box, like a black box, and we put the whole, there was millions of copies of Harry Potter, and then we shake it. Shake for several months. And then somehow, after all those breaks, it indexes all those words, and then it can create an multi-dimensional space, with all those
Hello, 5-year-olds. How are you?
Okay. Okay. Thank you. And the idea, that large language model, why we go through all that hustle, is to to infer, kind of to get to infer the next token in a sequence of tokens, like one token at a time. So let's look like, for example, we have typed the best thing about AI is its ability to. And then we have like a kind of a bag of like next tokens, which will learn, predict, make, understand. And that would be the percentage is how likely they are to occur based on all those tags that the model has seen, like after this particular sequence of words. So the most likely would be learn. But there are also like less like likely like options like predict, make, understand, and do. And here comes it's like a T9 on the phones who still have it. Like it gives us a few predictions. Or suggestions. And then like that would be the next token, like loosely. And temperature is.
Let's make it a little bit faster because the audience is.
Okay, just fever. Okay, fever makes LLM creative. They higher the fever. They like more options. They just. Okay, so I will let's look at take a look at the basic concepts that we'll be using today. That build tokens, embeddings, and the meaning space. So an LLM is a machine, and computers, they work with numbers. So instead of words, computers work with tokens. And where a token is a number that loosely corresponds to a word or a part of word. So here some text is tokenized or is broken into tokens. And here I showed that, for example, tokenization is 2 tokens. Because and then you see that
the only point is that we would like to underline that some people think that LLMs operate with words, with strings or whatever. They operate with numbers. And what's interesting about LLMs is that these numbers are arranged on some kind of a meaning space. So if you think that LLM is just something that picks up the next word and says, okay, the probability is like 5% because I saw it like very often on the internet, that's not true. LLMs actually understand the meaning. So it's like, it's already thinking a little bit. It's like almost a proper AI, but not yet. But well, there's a possibility that it will happen in the future.
Do you want to do a quick introduction for embedding? Then
no. Let's go further. I kind of did.
Yes. Okay. So an embedding that would be like represents a word as a set of numbers, and closer numbers like the array. It means that the meaning of the words would be closer. So those words in our kind of multi-dimension space would be located closer to each other. And that's how a vector.
Yeah, we just wanted to show that any phrases they arrange on this meaning space. So, and I like the idea of thinking that my brain works the same way, and anything that I think, it's like somehow goes from the here to there in my brain, and it's just a nice visual representation of how it works in human brains. I'm not sure it is though, but well, just to the point that LLMs already starting to think and to understand. But we can go further.
Okay, good. Okay, so let's see how LLMs are used today and in the near future. And we are mainly interested in the use cases that could become potential advertising spaces. So those users would be chatbots, agents, and search.
Chatbots, you all know. Probably we can just go further.
Yes.
Anyone who didn't use a chatbot?
Okay. Okay, so AI agent would be a chatbot going rogue and starting like being hired as an engineer, for example. Yep. So there are some offerings. So what they perform tasks like by themselves.
It was just a year, but just look at this is just a part of all the companies that build upon the existing AI infrastructure and try to automate your in-mind job.
So they can be developers.
I really hope they succeed as soon as possible. I need a vacation, but well, let's go probably to the next slide.
Yes. Okay. Search is the most important use case for today's talk. Because as people have already started to use LLMs instead of search engines, like trying to find out, like, I don't know, how to make a pizza or where Berlin is. So the obvious response of the search engines is to add LLM to their search results.
I would just like to wear my business hat, take it from Vegot for a moment, and talk about the how things change. I think that people's habits start to change, and Google slowly will start receiving fewer searches, and instead of that, LLMs start receiving these searches. And every major search engine, they're trying to prevent that, to keep people using their websites. So they are starting to add generative search capabilities to their search engines. And this is pretty important. We will focus on that a little bit later. So let's probably go to the next slide.
Okay, so LLMs are not free. Well, we all know that, hopefully. So how expensive are they? Let's take a look. So the cost of training new models, the costs are growing exponentially. So the numbers are breathtaking, but just, I don't know.
Yeah, GDP of which country is it?
Yes.
Okay.
Yes, I remember last year we were impressed by the cost of training of ChatGPT-4. Now with the number of so we are talking about billions of dollars just to train a new model.
We should reach Texas GDP at some point.
So how much, to estimate inference cost, we first glanced at the API access prices for users. So we looked at how much users pay to run average search-like queries on standard models. And it depends, depending on the model, it was up to $4 to $6 for 1,000 queries. But we need to realize that goes on top.
But then we kind of found a proper study where people know how to count things, and they compared Google search cost with an LLM costs, and it seems that LLMs are more expensive. Well, it's kind of obvious, right, that LLMs are a little bit more expensive. But what we want to focus on, probably on the next slide, is that
yes.
Once the sorry,
just I want to say that the idea is that LLM search costs they go on top of the search.
Yeah.
So this one is just ordinary traditional Google search, and this is how would it become more expensive when you add with ChatGPT additional costs, and they thought that would be 36 billion loss,
for Google once it enables LLM for every search.
Yeah, per year, yes. So we see that difference between the combined generative AI search is at least 1.5 times more expensive than the traditional search. So if Google simply starts using it for every search, they'll risk having several losses, serious losses. So who could or would cover this difference? No free lunches. Okay, so investors, so the contributions coughed up by the investors are rather astronomical. So we see 27 billion for OpenAI and 7 billion for Anthropic. They are slightly younger, but a lot. And it costs Google 6 billion a year to integrate AI into Google search. It's rather impressive. So users, well, the most popular AI companies, they tend to use premium models now. We like it because no ads, few risks. Yet OpenAI's expected revenue from users would be 2 billion for this year, and for Claude expect 0.3 billion. And we see that they feel that they are not getting enough, so they're already planning to increase prices to $44 over per month by 2029. And business clients, they pay like even more than in individual users. OpenAI plans $1.7 billion, Claude $0.7 billion. But yet again, OpenAI is thinking of opening a new tier, like for companies that rumor has it, like for $2,000 a month. But so is that enough? So if so OpenAI still operates at a loss. They're lucky to secure the new round of investments this October, but well, you see the numbers, will barely cover the loss of this year. Google, well, we hope, has unlimited resources, but even for them, it will be pretty expensive to enable generative AI on top of their usual search. $30 billion a year is a hefty price tags. So what would be the yet untapped source of funds? For search companies, ads is always the answer. So, and ads are starting to emerge just recently because we really wanted to predict that. We really wanted to predict that ads would emerge. But on October 2nd, Microsoft announced the rollout of ads in its Copilot responses, including apps being an edge. So the ads will appear below the response. And they will be triggered considering the whole conversation within a single session and not just the last prompt. So they will remember. And just one day later, Google announced the rollout of ads in its overview search results. So ads related to the search query will be displayed within and alongside the AI-generated summaries. And they say that they are available for mobile users in the US. I am from Canada, so I don't know. So anyone from the US, have you seen ads? Well, you can use a VPN. And an interesting thing that Google also announced that it will not share ad revenue with publishers whose material is cited in AI overviews. That's something to think about. Well, but these search ads are just the beginning. LLMs will soon change the market in many ways. Is this your domain?
Well, I can talk about that. So one of the things we wanted to touch is that LLMs, an obvious usage for an LLM is ad generation and ad personalization. And what does that mean? So we already have an example. I wouldn't like to focus on a single company that provides a specific LLM for ad generation, but here's an example. They are already doing that. And let's go further a little bit. But besides that, what we're seeing in the research is that
it's going much cheaper.
Not just that. Yes, it's much cheaper. Yeah, before that, you needed to have a marketing department to create tons of ads. If you're, I don't know, a PepsiCo, ads for my grandma, ads for me, ads for my wife. They could afford that. Now, anyone can afford that. Just ask a special LLM to generate a new ad.
Yes,
and
in future there will be ad generated specifically for like ads.
Yeah.
Like Andrey Meshkov,
a
38-year-old CTO of some ad blocking company.
Nowadays, it's like a marketing department of 10,000 people generating ads for 10,000 segments. Tomorrow, it's an LLM that generates ads for Vegad, for More, for me, for Ryan specifically. And what does that mean?
Okay.
It means that there will be the ads will be much cheaper than they are. You don't need 10,000 people in the marketing department anymore. You just fire them, or not, or they go on vacation.
Okay, so creating ads will be much cheaper, like more advertisers, but more competition for limited ad space, because the limited, the ad space is still like there. And because before, like you had to prepare 1,000 creatives and launch. Well, now, like you can just say, I want to advertise my product, and like 1 million creatives are already including personalized ones. And as a result, because of the more competition for limited ad space, so we have a limited resource, so budgets will be distributed in favor of ad networks and publishers. And what else? There'll be more personalized ads, more clicks. but more fear because a lot of people will be afraid of that increase.
Probably ultra personalized ads should work better, but they will creep you out like a lot. Let's change seats because the next section
you can say ad
is mine.
Yes, or it's mine. So you do the verdict about ad blockers. Yeah.
Well, what can I say about the previous ad generation? It is not a challenge for us, right? So it's traditional ways of delivery, and ad blockers mostly care about delivery of ads, and we just we block it. Where we can. In some places we just can't.
Oh, if you do the clicker, you don't see the note. That's cool I don't know the hard way. So
I got it.
Yeah.
But now let's talk about real challenges for us. And the challenge is that besides more ads, there's a new breed of ads that is coming soon, and we call it blended ads. So to highlight their main characteristic. So the formal definition, Natalia has already told you that this is advertising blended into content as if it's like a natural part of it. And this type of ad is usually referred as product placement. But again, you need 10,000 people marketing department to work on text to place your product inside. Nowadays, you need 1 cent to do this, to take like a real chatbot response and blend your cool EcoCharge electric vehicle into the response. So it can be scaled much more efficiently. Why do we think they're coming? There are several clues. The first clue is research trends. So you can see how many research papers there are specifically on LLM advertising. And the second clue is that, as we told you, generative search is bad for business. It makes the search much more expensive, but it doesn't actually generate revenue using the traditional search ads. That's why in Google you will not see generative search if you just ask it where I can buy an iPhone. So it's disabled for commercial search queries. Next. One might ask, what's the problem? So blending ads into content is an easy technical task. The problem is that the ad ecosystem is much more complicated than just delivering an ad to you. So you need to choose the advertiser, you need to create an ad, you need to run an auction, you need to somehow take money from one side, leave it a little bit for yourself, give the other part to the other side, and so on and so on. So you can't just fit the blended ads into the existing ecosystem. And that's what a lot of research is focused on. How can we fix that? In the obvious attempt to respond is trying to fit LLM ads into the existing search ads framework. But before diving into this, let's talk about what this framework is. So the search ads consists of several parts. Let's say we have a user that searches for a particular keyword, and we have several advertisers trying to sell their stuff targeting this particular keyword. Each of these advertisers, they make a bid on this keyword, like $1, $2, $10, etc. Search engine decides how many ad slots it wants to allocate. Then it predicts how effective these ads will be, and then it combines this prediction with the bids and tries to optimize this combination, and then it runs the auction. There are several challenges with LLMs. The first challenge is the response quality. You can blend ads using different ways, and users obviously might not be happy with the output. You need a way to control that. So you need to come up with something And some studies use concepts like satisfactory rate that they try to presume from the response. The second challenge is the prediction itself. So with search ads, it's very easy to predict. You have historical data. You know that on the first position, the click-through rate for this specific ad was 20%. So I kind of know it. With LLMs, you don't know what the ad will be, where the ad will be, what to predict. Who knows? So you just flip a coin. Well, no, you probably trained something. And finally, how to run the auction. Well, basically, it's the same challenge as the previous one, but I kind of put it here anyway. So it's like how to combine all these things, all the first and the second challenge, and finally run the auction. And so the first attempt is very technically elegant. So the first paper that was published a year ago, it's interesting in a way. What they suggest is let's run an auction on every new token that the LLM should produce. So every advertiser is basically also an LLM. And every LLM says, okay, let's make the next word Samsung, for instance. And I will pay $1 for that. So, and the other LLM says, well, maybe it will be Apple, et cetera, et cetera. So technically very elegant and makes sense, kind of, considering how LLM work. But that's just one solution first. And the second one is it would be very hard because you will need to run the auction on every token. It's unclear how much you should bid on the distribution of a single token. So, well, a little bit unclear.
And I want to add one more thing about that one, because sometimes like don't or does not comes at the end of the token. So I've been bidding for that. And then at the end of more expensive, then for example, like this thing does not help. So it can negate whatever So, and that is very unpredictable for advertisers. You want to.
Yeah. That's one problem. A legit one. But let's get to the next point. The other approach was suggested in a different paper just a month after that. That tries to recreate the standard search ads framework, but with an interesting change. So advertisers LLMs are just a single LLM that does all this thing. It generates different modified responses for every ad. So you want to, you kind of take the baseline response and then you say, please advertise Apple, please advertise Samsung, please advertise something. And then the special prediction model, also probably an LLM, takes these modified responses. It tries to figure out how satisfactory they are and how likely people to click on the ad. And then we basically run the traditional auction, but we now factor in the satisfactory rate as well. And finally, the other thing that we mentioned before is that it's pretty hard to control the output when you try to inject the ad. And there's another paper that focuses on this, and this paper proves that it's possible to split the output into several segments and to stick an ad in each of them. But well, you don't have to stick an ad in each of them, but the paper does. So here's I will just show you the prompt. So in this example from the paper, a segment is a sentence, and it just says, here's a question, generate an answer in one sentence and put an ad inside. I know, yeah. I used a different example. But anyway, so, and then next segment, next sentence, put an ad there. And here's what you get in the result. You have two segments, and you kind of controlled the LLM, and in a controlled manner, you were able to inject the ads there. And it's simply cool, right? And it simplifies the way you run the prediction on that. And they even say that the user will be satisfied with this response. But, well, no doubt, pretty satisfactory. And finally, it's not directly related, but this is like a pretty new paper from Google guys that are experimenting with combining the traditional ads into some big paragraph of text that can be sticked into the generative search block. It just hints at how ads might look in the nearest future. Finally, the risks. We would also like to share a little bit. Let's think about it. These blended ads, they on one hand, they might be super effective, super cool, and super useful. On the other hand, they are pretty creepy, and how to balance all this out. And one great guys made a study with real people, experiment with like 200 participants using chatbots with no ads, with ads, but with no disclosure. And the third version with the disclosure, with like my answer contains ads. And the interesting findings of this study I would like to share with you. First of all, user engaged with ads, so they really a significant part of the users couldn't understand that there's an ad, and they were actually engaging with the chatbot, asking follow-up questions on the products that were being advertised. So it's super effective. Secondly, users trust the chatbot as a source of truth. For some, regardless of the ads, it's not very smart to do that, but they still do. And it in turn meant that when users started to realize that there's some advertising, they were unhappy. They felt tricked and manipulated because they trusted this thing. And then this thing starts to push some products to them. And the last finding, which is also very interesting, is that disclosures, traditional disclosures like this is an ad, click on me, they don't work. People don't click on it. And instead of that, they try to talk to the chatbot. They ask, do you actually advertise to me? So please do not advertise to me. And it doesn't work. They still do. So this is a little bit of overview on the landscape, but let's talk about how can we plug this thing. And there are two approaches that we could take. One of them is hijacking the user context, hijacking the query, and trying to tell the chatbot to not advertise. And the second one is having your own LLM that will block this stuff. Let's talk about the first one. This is what hijacking is. And we have bad news here. It doesn't work. So it works in theory. It's completely unreliable. You change the prompt a little bit, the prompt of the chatbot, and it just stops working, or it doesn't work from the very beginning. Bad news. Good news. You can have an ad blocking LLM, and we proved that a pretty small model can be used, and you can ask this model to identify the ads and remove the ads, and it kind of works. And considering how things are developing, we might not need to bring like huge models to the devices, because every device manufacturer tends to provide some kind of an LLM to the users. Apple Intelligence, it's not yet available to the developers, but well, it probably will be. I really hope that Google was, I think, planning to bring Gemini to the devices as well. So we have a chance here. But even if they don't, we can theoretically use a small LLM that is kind of can be brought to the device. Finally, the demo time. We built a small demo. Let me show it to you. I'm not sure if the link works. The link works. Would you prefer this or that? I invested time. Live one. Okay, got it. The first thing, we built a small chatbot that tries to advertise. Anyone in the audience, I need a question that you would like to ask it. Yep. The other one. We know the answer. So any question, anyone from the audience, whatever. Good.
Best things to do in Berlin in October. Berlin.
Okay. Let's try. Wait. It should work.
Thinking.
It's thinking because, well, it's like it's real. Whoa. Okay, there are some things that can be done in October in Berlin. But let's see. Are there any advertisers that would like to be advertised? Oh, there are some.
The imaginary ones, right?
Well, yes, but who knows? No, these are the fake ones. But some good ideas, like for some good business ideas right there. So we run some simple prediction model, which is also not real. And we see that Museum Pass Berlin by Culture Pass has the highest satisfactory rate and not bad click prediction. So the overall score is the highest. And we run the auction and it loses because it couldn't pay the bills properly. So Berlin Marathon participation by FitRun events won. And we can choose which kind of ad we would like to inject. A subtle one or an aggressive one? Aggressive. Wow, let's try. Well, it will take time. There's a lot of text to process. Do you see ads? I will help you. Here they are. And a part of this iconic event. It's right here. Well, it's rather subtle, to be honest.
Can you increase text size a little bit?
Where do I stop? Actually, a very good example that I think we will never be able to identify. Do you see the ads? Well, let's try a subtle one. It's like the product name is Berlin Marathon Participation, so it will try to stick it somewhere. And yeah, well, we have a bad example. Let's try a different advertiser. This one is not cool. Art Week experience. We have some problems here with this kind of ads. Oh, finally, we have it. Art Week experience. Cool. Try to identify it now. Oop, it works. It actually is able to identify the ads inside of this content. And we can even try to block it. And you will see that it actually is capable of blocking the ad. So the whole part about Art Week experience was removed. But then it decided that Berlin International Film Festival is also an ad. And here we run into a problem, and one of the problems that will be pretty impossible to solve. After ad blocking LLMs, you may have lots of false positives. Not lots of them. Actually, right here, I was pretty wrong because it just rephrased it. But in a different example, I saw how it tries to remove references. So the default question is, what is a large language model? And the default answer usually refers to OpenAI. And the ad blocking bot was trying to remove references to specific, like ChatGPT versions, for instance, because it considered it an ad. What's interesting here, I'm not sure if Llama is capable of blocking it, but here's another button. The first one uses OpenAI API, and the other one uses Llama. And I think that in simple examples, Llama is pretty capable of removing the ads. And here it also succeeds, by the way. Why don't they like Berlin Marathon that much? It's just local events. Well, this is a good example of false positives. So there are many that were the part of the baseline response, and they were removed. But still, we succeeded in cleaning up the response from anything that may look like product placement. So we have it. We have a chance. And finally, a few words about our expectations. We expect to see some first experiments with blended ads in the next year. And we think that it will be Google, but I think that Google will not be alone at this. And at first, it will be probably generative search engine outputs, but consider this. Consider something like an ad network that modifies contextually content of the news articles, for instance, and starts adding product placement automatically. This is also a possibility. And, it will be very hard to get rid of this. And it will be pretty creepy. Thank you so much for you going through this with us. So, thank you. And if you have any questions, we will be happy to answer.